Gravity never sleeps. Every second of every day, it is trying to pull a building down to the earth, exerting an immense, invisible pressure on every pillar and beam. When a building finally gives way, it rarely happens without warning. That failure is simply the delayed physical reaction to microscopic errors buried deep within the walls, months or even years prior. This makes human estimation the most dangerous element on a modern construction site. Relying on a gut feeling or a quick visual check invites microscopic errors into the framework. Skip a single soil test beneath the foundation or place steel rebar just a few millimeters off from the design, and the load-bearing capacity of the entire structure above it is compromised. A building's long-term survival depends on removing human guesswork entirely, long before the first drop of concrete is ever poured. This is where consulting civil engineer Air Abubakar Bavakati steps in. He acts as the link that translates theoretical safety blueprints into physical reality. On a live construction site, he relentlessly inspects raw materials, measuring exact structural tolerances and enforcing strict engineering codes against the chaos of daily labor. Professional on-site supervision is the only guaranteed barrier protecting raw materials from becoming a collapsed structure. To see how those materials actually survive, we have to look inside the reinforced concrete column, the primary load-bearing soldier responsible for carrying the entire weight of a building safely down to the soil. This diagram shows compression, the crushing downward weight. Concrete naturally resists this, but under tension, a sideways bending force, the unreinforced material snaps instantly. To solve this, steel rebar is integrated, acting as a skeletal matrix to absorb those pulling forces. The column survives natural forces only when concrete and steel work together in precise, mathematical harmony. Mathematical perfection exists on the blueprint, but maintaining it on a chaotic construction site is difficult. Take pore compaction, for example. If concrete is poured too quickly, it creates honeycombing, trapped air and empty void spaces inside the pillar that shatter the downward load path. Or low cover, which happens when the steel matrix rests too close to the outer surface. Moisture seeps in, causing the steel to rust and expand, which physically breaks the column apart from the inside. Even adding a little too much water to the mix to make it easier to pour destroys the exact water-cement ratio, creating a weak chemical bond that starts degrading on day one. Poor execution at this micro-level erodes the safety margins calculated on paper, creating a structure that is physically incapable of reaching its intended lifespan. Civil engineers neutralize these risks by enforcing the exact specifications of the Indian Standard Codes, overriding visual estimates with hard data. This requires testing raw materials directly on site. Before a single drop of concrete is poured, they conduct a slump test to verify the precise water-cement ratio has been met. During the execution phase, they use mechanical vibrators to shake out the air and prevent honeycombing, while physically measuring the lap lengths to ensure the steel remains continuous. Disciplined, uncompromising adherence to these specific physical tests is what transforms fragile raw materials into a permanent, immovable shelter. Years later, the dust clears, the scaffolding comes down, and families and businesses move into the completed structure. They will notice the bright exterior paint, the glass facades, and the polished tiles, completely unaware of the invisible structural bones holding them up. Yet the daily safety of those inhabitants relies entirely on the engineering standards that were strictly enforced months or years prior. These unseen standards ensure the structure remains as stable and secure in 30 years as it was on the day it opened, providing a long-term reliability that no aesthetic finish can replace. Bhavika Construction maintains this standard through 3 core pillars: uncompromised quality materials, expert site supervision, and rigorous on-time delivery. Delivering quality construction is an indelible mark of professional integrity. Protect your investment and your safety by demanding professional civil engineering standards. Like, share, and subscribe to learn the mechanics of true construction.